So Prasun, we're now going to be studying the kinetic theory of gases, right?
Yes.
So what will we study in this chapter?
First of all, in the kinetic theory of gases, we start with the equation of state, which is PV equals to nRT.
Alright.
We look at what pressure is and what the volume would be, and n would be the number of moles and the gas constant. Then we see the assumptions behind the ideal gas, what a particular ideal gas is, or like what can we categorize as an ideal gas. And then we see the work done by the ideal gas, how much work it will do when the pressure might be constant or the volume might be constant, or pressure might be a function of the volume. And then we link all the kinetic theory and the ideal gases equation to the thermodynamics. And there we come across terms like Cp, Cv, which are the molar heat capacities for various processes. So that would be it.
That's the main thing that we're
Yes.
going to cover.
that
So
are the
what are mistakes that students make in this chapter that you've come across?
Mistakes are like this is quite simple because we have just one equation PV equals nRT, but the mistake that can be made is in the units. Because if we want to keep the units as SI, then we should keep in mind that we do it for everything, for all PV, nRT.
Okay.
And if it has to be CGS, then that, but the units have to be kept in mind. And another thing is there that we should know that what a particular system is, what gas we have to apply that equation, whether the ideal gas equation can be applied or not. Because say if a gas is flowing and the pressure is not constant at every point, then we cannot apply that to there.
Okay.
So the basically PV and nRT all have to be defined if we have to apply the equation.
And we've got to be very careful when we're doing this.
Yes.
So, Prasun, what interests you in the topic? Like, what have you found fascinating
Yes,
about it?
what was very fascinating that we could express temperature as a function of the kinetic energy, or basically the kinetic theory defines the temperature, which is a basically thermodynamic property,
Okay.
and we know the kinetic energy is a mechanical property. So I
Okay.
never thought that this could all be linked together, and it could be linked in such a nice way that we could use it so properly. And then if we go to real gases also, if we see the equation, then this is also based on corrections done on the ideal gas.
Okay.
So it basically tells us that roughly how materials would behave, and that is very interesting to know at various temperatures and pressures.
So in this chapter, we understand how microscopic properties and motion of particles can result
Yes.
in large-scale gross properties like temperature
Yeah.
and how they're correlated and how the entire thing works out.
Yes.
So it's a top-to-bottom approach, as we call it. So sounds fascinating. Let's jump into the questions and try and solve some of them.
Yes.